Okay, hi guys. So this is Jay Pipes. He's a MySQL employee. He's in charge of North American community relations. I met him this week at the MySQL user conference, which is down in Santa Clara. Now, the deal is that we're going to host this on Google Video, so if you have confidential questions, if you could leave them till the cameras are turned off, that'd be cool. With it, no more ado, Jay Pipes.
All right. Nice to meet all of you. I'm going to be giving a talk that I gave on, I think, Tuesday or Wednesday on performance tuning best practices for MySQL. Some of the things are version specific, but for the most part, it's pretty general. We're going to be covering profiling and benchmarking core concepts, sources of problems that you might encounter, index guidelines, schema guidelines, coding techniques, and lastly, we'll go over some general things about tuning server parameters. Since the audience is, I think, sort of mixed levels of experience, we'll just shout out questions or tell me if you want some more advanced stuff. So, all right, benchmarking concepts. The general idea behind benchmarking MySQL is to obviously have a track record. You know, when you change things in your code in your application or the configuration files with MySQL or your schema design or your indexing, you want to make sure you have a track record of what you're doing. Because a lot of times if you don't keep a track record and don't do benchmarking, you won't really know whether a specific change that you made had a detrimental impact or whether it actually increased performance. So the baseline, you always want to have your baseline for your starting point, and always give yourself a target. Don't just do it so it's a moving target. You always want to have an end goal. You know, you either want to get 20% increase in performance, that's your goal, but just don't have it just kind of end with nothing, because then you'll just spend years and years and years trying to tune milliseconds out of your application when there's really no benefit to it. So change only one thing at a time. Pretty basic concept, but it goes a long way in benchmarking. If you change two things and you rerun a test, how do you know which one of those two things actually affected the difference between the two tests? So always change one thing at a time and rerun the benchmarks. And record everything. Configuration files, information on the hardware, information on obviously the operating system, the version of MySQL, and everything to do with the benchmarks. Keep it in a separate folder and keep everything for a historical record. A lot of times you'll think that you won't need information when you're running benchmarks, and then 6 months later you realize that, wow, it would be really useful if I had, I threw it away. So always keep information from your benchmarks so you have a historical record of what you did. And specifically with MySQL, you want to disable the query cache whenever you're running benchmarks. The reason is that it will skew the results that you get from read-intensive queries and write-intensive queries as well. So disable the query cache by setting the query cache size equal to 0 when you run benchmarks. So, yeah, go ahead.
I was trying to do benchmarking before. It seems like a real problem with the operating system caches were affecting the speed of the run.
Right. Yeah, the question was what you were experiencing, that the operating system caching was skewing the results of the benchmark. Generally, the idea is either you can disable caching if it's actually getting in the way, or if you bump up the actual number of runs in the benchmark test, you can minimize the skew effect. So that's usually what we recommend. But when you get into specific caches, there's very specific things to do. So it would kind of depend on the exact scenario that you're doing. So, but yeah, bumping out the number of runs in the benchmark generally tends to mitigate a lot of that. So, does that answer your question? Okay. Profiling concepts. Profiling is a little different than benchmarking. Generally, you're profiling a production or a running test system that you're trying to figure out, diagnosing what's going on while it's running. So instead of doing finding the stress or the load that the system can take, you're actually trying to pinpoint where the bottlenecks are in the code while it's running. With MySQL, the best tool that you have is the explain command. So regardless of what version of MySQL you're running, you really want to get familiar with everything in the explain command. Understand what the access types, does everyone know what the explain command is? Everyone use it? Okay. Does everyone know what every single type of access type is? Okay. It's sort of a poorly named column in the explain results, but it actually describes the path or the optimization pattern at which the optimizer is saying, okay, well, I'm going to access this result set and join it to this result set, and each of those things, the ref or null, the ecref, range, all the different access types mean different things, and the performance that you get from each of them, you can go into the MySQL manual depending on your version. You can see which ones have a better performance for different types of queries. It's not always the same. So you want to make sure you understand those. Understanding, obviously, that if you see all in the access type, it means it's doing a full table scan. Just little things like that. Be aware of what they all mean and what the performance impact of the different ones are. So using the slow query log and MySQL dump slow to parse the query log. Very easy to set up. You log slow queries, and then you give it a long query time. Anything above that, it'll log to the slow query log. There's also, I think in 4.1, we put in an option that you can, any table, any select statement that does not use an index on a table can get logged to the slow query log, regardless of how fast it runs. And that's useful for when you're doing an indexing strategy and you're trying to determine, okay, my patterns of access. Do I have indexes on those fields that I'm actually accessing, in my where clause and on clauses and that kind of thing. So low-hanging fruit, law of diminishing returns, tackle stuff that's going to get you the absolute best return on investment for your time. Don't concentrate on, I know you guys are Google, so a millisecond definitely does count. But if you've got a choice of, going from 5 milliseconds to 4 milliseconds or going from a minute to, a second, it's a no-brainer. Concentrate on the stuff that's going to give you the biggest impact. Using MyTop, Jeremy Zawadny wrote a nice little tool. Most of you are probably familiar with the top utility in Unix. It's almost identical, but it's just for MySQL. And it gives you an ability to, on a repeating delay, show you the process list of what's going on in MySQL and show commands, the status variables, and gives you a nice little interface to profile into the system while it's running. And the one nice thing about MyTop that I really like is that you can use it for remote hosts as well. So you can run it on your local machine and access a remote host. So that it is a nice little tool. Okay, sources of problems. This is kind of my personal opinion of where I rank the law of diminishing returns, like what I actually go for immediately. The performance team tends to think that sometimes you can tune a server parameter and that's like the biggest bang for the least amount of time. But I think really where performance problems come in are definitely the top three here. Poor indexing choices will kill an application faster than really anything else. If you're querying on a field and you don't have an index on it and you're repeatedly hitting that, it's going to kill the application faster than whether sort buffer size can be adjusted. So same thing with inefficient or bloated schema design. I talked in the performance talk. I've seen a number of cases where people designing new applications will actually denormalize from the beginning because they think it's going to give them better performance. Don't do that. There's specific cases where you can denormalize a schema and you can get some performance benefits, but don't do it right away. Just because you think it's going to get a performance benefit. Use good, efficient, normalized schemas. And we'll go into detail on this later. Bad coding practices. MySQL has some inefficiency problems with subqueries, but in general, using joins is a lot more efficient than using subqueries. We're going to go show some examples of specific where you can really get a performance increase by just simply changing the way that you code SQL. Server variables not tuned properly, yeah, it's a source of problems, but in my opinion, very specific situations can be helped by tuning server parameters. It's not some catch-all. It totally depends on how much memory you have in the machine, what the architecture is, what operating system you're running on, what version of MySQL, what storage engines you're using, the type of application that you have, whether it's OLTP or heavy reads. All these things. Yes, tuning server parameters can help, but it's very specific to certain situations. And it also requires retesting and rerunning. You tweak one thing, you have to run the benchmark test to see if you got the performance gain out of it. It can be time consuming to tweak server variables, whereas it's pretty easy to change some SQL statements and immediately rerun it and see if you've got a huge performance gain from doing that. And finally, hardware and network bottlenecks, I/O, CPU bound, network latency. There is a good book that I brought along that I recommend for that, and when we get to the last slide, I'll show you that. So, all right, indexing guidelines. Poor or missing index, definitely the fastest way to kill an application, like I said. Look for covering index opportunities. We're going to go into some slides here to kind of explain what that is. But a covering index is, especially for who's using MyISAM versus InnoDB? InnoDB, raise hands. MyISAM, raise hands. Nobody's using MyISAM for a single thing. Okay. Say again? Gotcha. Okay. We'll explain some things about covering index opportunities that are very specific to InnoDB. But covering indexes, basically what it means is that the MySQL can get all the information from the index records, which are, by definition, slimmer than the data records because they don't contain all the fields in the table, and use that information to complete whatever the query was without having to go into the data records. One of the key concepts is the slimmer that your index records are, the more that you can fit into a single index block. And the more that you can fit into an index block, the fewer reads you're going to do, the faster your application is going to be. So covering index opportunities, definitely look around for those. When you're deciding on which fields you actually want to index, make sure you take a look at what the selectivity of the field is. Selectivity is the cardinality, or the number of unique values that are contained in that field divided by the total number of values in the table. So obviously a unique index would be a cardinality of 1, because it's unique over the total count. That's obviously the best case scenario, but you can get situations where you've got awful selectivity. If you're querying just on that index, or just on that field, you may get awful performance from that, or it may just decide not to use the index because it ceases to be useful. I think generally, Timur could talk a little bit more about this, but I think the number's about 30%. If the optimizer sees that, okay, you do a query, select, start from whatever, where column A equals 2, and it'll take a look and see an estimate from what the information that it has on the index. Will this particular query return around 30% or more of the rows in the table? Well, if it does, it's actually much more efficient to just sequentially scan the table than it is to go into the index and randomly seek and grab a bunch of records and then do lookups back to the data records. So be aware of the uniqueness of the values in your index. For lower selective fields where you don't have very much selectivity, you can sometimes tack them on to a multi-column index, so that, especially with group by queries, and we'll show an example of this, you get some efficiencies there. But just be aware of the selectivity. So, on multi-column indexes, like I was kind of explaining just now, the order of the fields is very important. You have to look at the queries that you're running against the database. If you have the columns mixed up or they're not optimal, the optimizer just won't use the index. And I'll show you a perfect example of something that happens all the time with this on group by queries. And as the database grows, you want to ensure that the distribution is good. If you set up an application, you're writing a new application, and you go through a couple months and you got a couple 100,000 records in there, okay, great. Everything looks great. The index strategy that you designed for it is wonderful. But that doesn't necessarily mean that in 9 months, you've got millions of records in there, that the index strategy that you initially picked out is going to be optimal. make sure that you understand how your data changes over time. If business practices can change. And so if you've got values, let's say you've got 7 values in a field, right? And you've got an index on that, 7 distinct values that you're putting into like a status field, okay? And over time, 90% of the field values contain one specific thing. That index ceases to be as useful as it was when you initially designed the application, because 90% of the rows contain the same value. So just be aware that as your database grows and your application changes, that you need to re-examine what you initially thought was a good index strategy, okay? Remove redundant indexes for faster write performance. Obviously, every index that you put on a field, you get a slight performance impact on writes, because it's got to write an index record as well as the data record every time you do an insert, and every time you update, if you update the key value, it's got to write to the index. So unfortunately, MySQL allows you to create redundant indexes on the exact same things. So I've seen cases where you get 40 indexes on a table, and 10 of them are redundant. Because over time, teams of people work on it, and no one wants to change other people's stuff. So they just add their own indexes and with different names and all that. But they're redundant. They're on the same fields. So as time goes by, make sure you check, remove redundant indexes to get some write performance. Okay, common index problem here. Kind of a Web 2.0 example. You got a tags table, which got tag ID and text for the tag, and a products table. Both of these tables have an auto-incrementing primary key. And then you've got a relationship table that stores the many-to-many relationship between products and tags. And if you notice that the primary key on this products to tags table is product ID, tag ID. Make sense? Pretty basic. Okay, here's 2 examples of pretty common queries run on this products to tags table. Only the top one's going to use the index on it. And the reason is because of the order of the columns in the index. On the top one, you're grouping by what's essentially the product ID. And so it's going to be able to take that left side of the index and use it in order to count the right side value, which is the tag ID. Now on the bottom, you're reversing that. You're saying for each distinct tag, give me the count of products. It can't use the index. It can't use that primary key index. So it won't use it. Get no read performance from it. The remedy would be to create an index that has tag on the left side. Okay? Now, there's 2 examples here where it says create index, the top example, create index IX tag on just the tag ID. For all you guys using InnoDB, that's exactly what you'd want to do. For MyISAM, you'd want to do the bottom one to create a covering index opportunity. Does anyone know why the top one should be used for InnoDB and not the bottom one? What's the difference between the secondary indexes in InnoDB versus MyISAM? Exactly. Because it's a clustered index organization in InnoDB, every time you add an index on a field that's not the primary key, every non-primary key index, the primary key is actually appended to every single index record. So if you've got a primary key product ID, tag ID, and you add an index on tag ID, product ID, you're being redundant because you've already got the product ID actually in the index record in InnoDB. So it's important to understand what the difference between the clustered organization and the MyISAM, which is non-clustered, where it's just a record number that's attached to each index record instead of the actual clustering key. So be aware of those differences. So when I was talking about redundant indexes, that one on the bottom would be redundant for InnoDB. Did the mic just change? No? Okay. Okay, sorry. Schema guidelines. Inefficient schema, another great way to kill your application. Use the smallest data types possible that you really need. If you don't have 4 billion rows in a table, don't use big int. I mean, it's just the basics, Keep them as trim as possible. If you have maximum of 100 values, don't use int, use tiny int. You can fit 255 unique values in it. Don't use char 200 when a var or a smaller char will do. Little things like this make a huge impact in performance. And the reason is, remember that every index record has got to contain that width. So if you've got an index on a char 40, every single index record's got 40 bytes in it. And, well, a little bit different because there's some index prefix compression that's going on, but the general concept stays. If you have an index on first name, just index the first 10 characters of it or the first 15 characters of it. You fit many more index records into a single key block, and therefore you get fewer reads, faster performance. When you've got many columns in a table, especially many nullable columns, consider splitting the tables into two tables, like a main and a detail table or something like that. If you've got many nullable columns or columns that are rarely even accessed or rarely searched on, put those in a separate table and join them on a one-to-one relationship. Okay? And the reason for that is you can pull many more of the main records that you're actually searching on into memory. Especially if you don't need the detail records of those fields, you can have a lot more opportunities to get more performance from that. Consider vertically splitting many road tables using partitioning or the MySQL merge tables, which, since you guys are using InnoDB, doesn't matter. Partitioning is in 5.1, so you guys are a little ways away from that. All right. You can also do your own application level vertical partitioning, where you're naming different sets of tables and then using views. On the one person that was using 5.0, you can use views in order to aggregate many tables into a single view. And always remember the fewer reads equals faster results. And this is the limit of my graphical ability right here. That's about it. It's just a little flow of smaller data types leads to narrower index records, more records per block, fewer reads, faster performance. It's just the general thing. How to get better performance from your indexes in the schema. InnoDB, choose the smallest possible clustering key. Since, like I just explained, it's appended to every single secondary index record. So if you've got a 12-byte primary key on your index on your InnoDB table, that's 12 bytes per index record that are being appended every single time you insert into the table. So be aware of that. Don't use surrogate keys when a naturally occurring one exists. We see this all the time in the forums. And I often wonder what the use of it is and why people do it. You've got a naturally occurring product ID, tag ID key. It's a naturally occurring primary key. And yet a lot of people will just kind of put an auto increment in there just for the heck of it, But you're never really going to be looking up by record ID. You're always going to be looking up based on product ID or tag ID. So some people call it a surrogate key or a false key. Get rid of them. It's just wasting space. Coding guidelines. I tend to call it chunky coding habits. Cutting everything down into the smallest possible units you can. Thinking of SQL in terms of procedural programming is a bad idea. It leads to, well, correlated subqueries and other things I hate. You want to be an SQL programmer that thinks in sets. Don't think in terms of for loops. Okay? Think in terms of merging and intersecting sets of data, and you'll be able to cut it up into chunks, and you'll be much more efficient in the way you code SQL. The 5.0 guy. Use store procedures. If you're not using store procedures, you're missing out on a performance increase in 5.0. InnoDB, how many of you are using select count star on InnoDB tables? I know there's some of you. Okay, don't. InnoDB cannot optimize select count star queries. Okay, so your table and your schema will not scale well. Okay? The more records you get in there, it requires actually reading through and counting all the records. Whereas with MyISAM, it can actually get the count from the index. With InnoDB, it cannot. It actually has to count all the values. And the reason for that is the way that InnoDB implements what's called multi-version concurrency control. And there's a version so that the row level locking can occur in InnoDB. There's a version for each row. So there's complexities involved with actually counting, the number of values because, well, which version are you comparing? And so use counter tables. So if you're doing, select count star products, have a separate table that stores the number of products. And when you insert into the product table, increment it. When you delete, decrement it. Okay, that's how to scale InnoDB for performance. We've seen this bite a number of big forum applications. That they always do count of the number of threads and the count of how many users are logged in. This was a big problem when if people switch from MyISAM to InnoDB without looking at the code, just simply switch the engines. It was a
Also consider you don't actually necessarily want to know the exact number of rows. Do you care if you've got 1,000 threads or 1,100 threads? It really doesn't matter. You want a ballpark figure. So even if your number is not fully up to date, it doesn't matter. If you want to run a cron job that does the InnoDB count once an hour, then put that value somewhere. You could put it in another table. You could put it in a file that you include into whatever page is displayed. That works fine. Then you reduce the problem to once an hour rather than every time you run that query.
All right, isolating indexes or index fields on one side of the equation. Your basic math class, you want to put the single on the one side and have your equation on the other. We'll show an example of how to do this in a second, and using calculated fields when they're necessary. Let's go on to the example of isolating indexed fields on one side of the equation. Okay, here we've got whenever you apply a function to a field that's indexed, the optimizer can't use the index on it. Okay, so you want to look for opportunities where you can rewrite SQL statements like on the top here into the exact same SQL statement or the exact same result, but you've isolated the index field without any function operating on it on the left or whatever, right? And just converted the actual statement into just a different way of representing it. Okay. Now, in this case, you're just taking the 2 days and converting it into current date minus 7 day. Just make sure you understand the greater than and equals and all that. So you're including it. Now, what's wrong with the second part? Well, how can we improve that with our performance? Anyone know? Say again? Yes. Well, yeah, basically that. The current date function is a non-deterministic function. And the problem with that is that the query cache won't cache this query. Well, the thing about current date is it only returns a different value once every, 24 hours? So if you're running this, let's say 100,000 times in a day, instead of running this once, it's going to run it 100,000 times. With the query cache, it actually puts the query into the cache, stores the results, and every time you issue that exact same query, it just takes it right out of the query cache. Never even has to hit the storage engine, the MySQL, whatever. It just takes it right out of the query cache. So in your Perl script or your PHP script or whatever you're using to write, just insert the date instead of using current date. Okay? A lot of people don't realize this, but very good way to get performance out of your query cache. Okay, using calculated fields. When you got where email address like %.com, index can't be used. The reason is because you can't have a wildcard on the left side of a constant, comparing it with like. If you put the wildcard on the right, on the end, and you have a constant string and then wildcard, the index can be used because it can look at the left side of the values. Okay? So the way to do this is to do a little trickery and put a reversed email address actually in your table. Okay? With 5.0, you can use a trigger that actually inserts the reverse of the email address that you're inserting directly into that new reverse email address field. Okay? And then on the bottom, you can just do the like reverse concat, and now you actually can use an index on that field. So that's a way of using calculated fields or fields that store different values based on other fields in the table to get performance out of something that you'd never be able to use an index on. Yeah, I mean, this is something, if you have an application that's looking up, all the email addresses in your database that end in .com or AOL.com or whatever it is, you don't want to be running that top one every single time someone requests that. You want to be operating on a reversed email address and using the index on it. Okay, learn to use joins. Like I said earlier, eliminating correlated subqueries is a great way to get performance out of your application currently. Like Timur, who's going to be speaking in a little bit, is on the optimizer team, and he's working on subquery optimizations. But there's just a better way of doing things with joins. Okay, it's easier, and it follows the set-based programming principles of SQL instead of the procedural language principles that most of us are very familiar with. The for loop, the operating on everything one at a time. Okay, so let's go into some examples here. Oh, don't try and outthink the optimizer team. Timur's pretty smart. You'll meet him in a little bit, but he's really smart. You can give the SQL server, the MySQL server, a join hint using like straight join. But the problem with that is while you may get some performance benefit if the optimizer currently can't figure out the right path, and I've only seen this in like 1 or 2 instances. But in 2 months, your data set changes, and the optimizer that you've now overridden with your straight join hint, now you may have the suboptimal plan for it, and you forgot that you put straight join in there, and now you've got a suboptimal plan. So if you are going to use a join hint, make sure you thoroughly document where you put it in the code and don't forget about it. Because as your data set changes, the optimizer could much more easily pick an optimal path for the query execution. So. Okay, eliminating correlated subqueries. With 4.1, it looked like most of you are on 4.1, you can use subqueries. I tend to avoid them like the plague. We see this a lot on the forums, this kind of thing. If most of you, like advanced SQL programmers, would probably not do anything like this, but we see it every day. The thing is to try and get the maximum sold price from an order items table for each product. And the procedural programmer, who's a Perl coder, doesn't necessarily, isn't familiar with SQL, hasn't been trained in set-based, thinking. This is a very natural way of doing something. You're saying, okay, I want my products table. I'm selecting from my products table. Okay, and I want each of those products. And for each one, I want to get the maximum price that it was sold in the order items table, correlating on the product ID. It's a very natural way for a procedural programmer to think of things. But remember, it's for each product. That's the way that people think about it. That's not the set-based way of doing things. On the right is the set-based way. You're joining. You're saying, okay, I've got 2 sets of information. I've got my products, and I've got my order items. Okay? And I want to transform these order items by grouping them on a product ID, and then finding the maximum price. So that's my set. The maximum prices for each product ID. And then I have my product set, and the maximum prices set, and I join them. That actually is 2 operations, right? 2 conceptual operations. Grouping and joining to the products. On the left, you're actually doing a query for every single product. So it doesn't scale. It's a linear model. So as you have 1,000 products, you're doing 1,000 subqueries to get the maximum price from the order items table. You have 1 million, you're doing 1 million queries. You're still doing 2 queries on the right. So think about how you can get rid of correlated subqueries. This is one of the best ways to get better performance out of your SQL code. Using derived tables. This might seem like a big mess, but it's actually more efficient on the right. And it goes back to the same principle of how many queries are you actually issuing. On the left, you've got a join from customers to orders. And in the where clause, you have a correlated subquery with a group by in it. Okay? Not a group, with an aggregate. So you're saying the customers join to the orders, but I want to group by the company of the customer, not the customer ID. And an order date equals the maximum order date, or the last order date in the orders table where the customer is the same, is correlated to your customers table C. And then group by the company. Well, you're going to be doing a subquery for this select max for each customer in the orders table. Now on the right, we say, okay, I have this customer set, and we're inner joining on what's called a derived table, a subquery in the from clause. That's one set. We're taking the maximum or the last order date for each customer, distinct customer ID in our orders table. That's a set. And then we're joining back to the orders table. So there's three operations, three conceptual sets to get that result, versus the non-scaling method of a correlated subquery in the where clause, which has to be executed for every single customer in the orders table. Okay? All right, and this is my last slide, and I tend to kind of skim over server parameters because I'm very happy to talk specifics with any one of you, but to generalize about server parameters, it's okay, but there are very specific situations where they can help, where you can get some definite performance boosts. Be aware of which server parameters are global versus what's per thread, per connection made to the database. Okay? For instance, key buffer size, it's a global variable. Sort buffer size, it's per thread. So be aware of that. Don't assume that sort buffer size is for the whole database and bump it up, because it's actually per thread. So make small changes, preferably a single change to your configuration file. Retest. See if you get a performance benefit from that specific change. Often provide a quick solution, but they can be temporary. Really the performance benefit is optimizing your application, your indexes, your schema, your coding. Query cache, it's off by default. So the size is 0 for your query cache, so if you haven't changed it, it's not on. You can do show status, and it'll say query cache type, I think it's query cache type on, but there's no size to it, so it actually isn't used by default. So unless you turned it on, you're not using your query cache. If you're doing read-intensive applications, like how many are doing like lots and lots of writes versus lots and lots of reads? Who has 90% reads or more? Okay, do you have your query caches turned on? Who has the query cache turned on that they know they've added size to? One guy in the back, all right. 2, all right, excellent. Okay, if you're doing read-intensive applications, turn the query cache on. Why? Because it doesn't have to execute the query. If it's the exact same query and your data set isn't changing much, it just takes it directly from the query cache. The query cache actually stores the result set. It doesn't just like compile the query and store the query so that it can be re-executed. It actually stores the rows so that it doesn't actually have to do any of the parsing or anything in the optimization. It just sends the rows right back to the client. So if you're doing repeated queries like that, turn the query cache on, give it some size. In the configuration file, it's the query underscore cache underscore size. Set it to whatever, 32 meg, 64 meg. You can play around with it. You can also do it online. I think it's set global query cache size equal something or other. It's in the menu. So you can do it online, or you can do it in your configuration file. Be aware of, since you don't use MyISAM tables, how many of you think that you're not using MyISAM at all? I hope not. Okay. The MySQL internal database is in MyISAM. Okay? So that's why if you do show status, you'll see actually that you have MyISAM operations going on. So even if all your tables are InnoDB, the MySQL internal database is in MyISAM. So you still need to put something in there. So leave the defaults for key buffer size there, so the MySQL database can live happily. But the InnoDB buffer pool size, that's your main one for InnoDB. That determines how much memory is allocated for storing data and index pages in InnoDB. I think Heki recommends about 50 to 80% of your total memory on the box should be allocated to InnoDB buffer size. Okay. Other important InnoDB stuff is the InnoDB log file size and log buffer size. I think he recommends that the log buffer size maxes out at 4 gig, but you can adjust it depending on what your situation is. And I can take some questions. Oh yeah, memory is the cheapest, fastest, easiest way to get better performance out of MySQL. Don't even ask your boss. Just stick another piece of RAM in there. It really is. MySQL just loves RAM. The more RAM you give it, it's like Pac-Man. It just eats the stuff up. It loves it. So that's the easiest and cheapest way to get better performance from a hardware situation. Yeah?
Sorry, I'm wondering, so things got a logical key in which
Okay, the question was, and if you've got a logical key in a character field, right? Say, for instance, I don't know, social security number, something like that. Is there a benefit to making what you're calling a surrogate key out of an auto-incrementing ID? There is a benefit to that, a big benefit to that. Depending on especially like if you have a char 4 versus an int, you're probably not going to see much of a performance difference. But if you've got a char 8, char 16, that's your product ID or your record ID or whatever it is, versus an auto-incrementing key, you're going to get a lot better performance from the numeric data type in 4 bytes. It's optimized for that. So. Okay. There's that string data type that we need. You mean versus like varchar 4000 or something versus text or whatever? There's some, maybe Arjen can talk to that. I don't know if there's a specific, how much performance benefit you get from doing varchar versus text. I think in InnoDB there may be something, but.
Yeah. Well, so the question is there a benefit to using char rather than varchar in certain cases? Or text versus varchar. In my ISAM, text fields are actually stored separately, text and blobs. The actual row contains a pointer to where the text field is. In case of a char or varchar, it's part of the row. In InnoDB, same up to a point. In certain cases, you will just find everything in the row. It depends on which version and so on. InnoDB itself doesn't care whether things are chars or varchars. It always internally uses varchars, basically. So in InnoDB, you don't need to make that distinction. Okay, I want to optimize for fixed length fields, that kind of stuff. It doesn't care about that. My ISAM would care. So that's the basic story. Does that answer your question? Okay.
Any other questions? No one? All right, well, thanks guys. Thanks for letting us come here.